All right, it's time to announce our lab manager for today. We are joined by Charlie. Charlie Gao, would you like to introduce yourself?
Sure. Hi, everyone. Nice to see you all. I'm Charlie Gao. I'm a member of the open source team at Posit, and sort of icebreaker. I have on this conf t-shirt from Seattle in 2024, and as you can see, this is actually a participant's t-shirt. So Isabella has a green one of the staff t-shirts, and so. The conference, 2 conferences ago, I was a member of our community, and it was really after that conference that I joined Posit. First as a contractor and then full time. So what do I work on? Well, work on sort of a number of things across open source. What I've been working on most recently is actually been Quarto. So I've been actively involved in Quarto 2, which is the new Rust rewrite. That has been announced, so I'm free to sort of say that. But as part of that, you will all be getting a collaborative editor. Yes. So that's been an incredibly exciting project to be working on. But apart from that, I'm also the creator and maintainer of a few R packages, Mirai, 99x, Secret Base, etc. And these are all packages that are mostly written in C actually for high performance computing and networking. So myself, I'm very deep into sort of async apart from working on Mirai, which is the package I'm probably most well known for, I've also implemented modern async into packages that you all use, often like Hitherto and Elmer. I also
Amazing.
maintain I also maintain the later package on behalf of Joe and Winston. Those are packages that they created very early on, and I've sort of taken over the maintainership as they've focused more on AI related applications. Later powers the core event loop in Shiny and other sort of key R packages like Plumber. And it is basically a way for different packages to cooperate with each other, even though they're running at the same time. So as you can see, I'm very much into sort of async, into sort of working on our internals, C code, and also communications. So this is like HTTP, WebSockets, and hence my work with Shiny and now on Quarto and the collaborative editor. So today I'm mostly going to be focusing on Mirai and how to use that for parallel and async programming.
Yes, I would love to start with what the heck is async programming and how is it different from parallel?
Sure. So let me just hit that on the head very like straight away so we get rid, we cover all the sort of technical jargon. Ace parallel is basically when you're running two things at the same time. And async is just you're not waiting around while that happens. That is as simple as I can put it. So let me share my screen and I'll give you a concrete example of what I mean by that.
Yes, please.
Okay, I'm going to be sharing my whole desktop and you see my Zoom screen, obviously. Okay,
Can everybody
okay.
see okay with the size, or does anything need to be zoomed? Now is the time to let us know. Brian says he's
So
okay.
if I'm typing stuff like this, is everyone going to be okay?
Let's see. Russ says size is okay. All
I've
right,
zoomed this in already, so this
we
is
have
yeah.
some thumbs up. Okay. If anybody
Okay,
needs us to stop, let us know. We'll make it bigger.
excellent. This is actually before I even start with any code, if I just switch to the the package downside for Mirai itself. This might be if I just try and zoom this in. Yeah, okay. So Mirai is sort of the main package I'm going to be talking about today. This is a package that I developed about three to 4 years ago is when I started work on this. So this is much more recent than any other sort of parallel code that you will see in base R. That code has been around for 20 to, I'm not sure if it's 30, but it's at least 20 years, and that hasn't changed. So this is sort of a much more modern take on how to run R code in parallel and async. Mirai is Japanese for future, for anyone who's wondering. So this is an implementation of future. So it's basically a computation that's going to be ready sometime in the future. And Mirai just is future in Japanese. So that's why it's called Mirai. And maybe while I'm here on the website, just a digression before I get onto code. And this is mirai.rlib.org. So Mirai, sorry, it's getting on. So this is just mirai.rlib.org. You'll see there's this Ask Deep Wiki button. And this is on a few POSIT packages. We use this on the Quarto side itself because Quarto is very complicated. It has a lot of components, and this is just an easy way for users to ask questions. So you can click in, and this is sort of AI LLM powered. There's ways that you can use this programmatically, but essentially you can click in and it's sort of it gives you like in-depth overview of like everything that's within Mirai, like its documentation and its functions. But the great thing is you drop straight into this sort of chat box that you see here, right? And you can ask any question that you have about Mirai. So even after this lab is complete, you can just go in and you can ask any question. And the great thing about this is you can put in your question in any language, and it will give you the answer in your own language of preference. So if I say something like comment utiliser Mirai avec le SSH
Wait a minute. Do
in
you
French,
speak French, Charlie?
un petit peu.
Sudden lore drop. Charlie
So
speaks French.
um, no, I haven't really used it since like school. It's just when I learned it. But you can see, this gives you like a nice answer, gives you examples, runnable code, etc., in the language of your choosing. And this is like going to be more helpful if you're, in like working Japanese or Chinese or something like that. It's like it's really sort of, powerful, the sort of AI LLM power tools that we get nowadays. Um, but that's sort of like a nice affordance that's just there on the homepage for Mirai. So I'm going to switch back now to my Positron window. And if I just spend like a couple of minutes again, I'm sort of like delaying the point where I actually like write code.
You're
But
killing me, Charlie. You're killing me. Show me
just
async
building up the
programming.
suspense. So you can see like what I have here is basically like the two-pane like view for Positron. And I think this basically gives you a clue that I'm more of a software engineer than a data scientist because I don't have the default data science view. And like, if you're curious about how to get there, it's really simple. If you click on this layout button, it's the side by side, and you just enable the sidebar, whatever it's called. Yeah, the sidebar. And the sidebar gives you all the usual tools, say files, search, git, integration, etc. And you can see I have these buttons along the top. This is also key to sort of the whole ergonomics of using Positron. And this, you've probably seen this before because this is, I'm sure Libby and Isabella has gone through this, but the default is this activity bar is the default is sort of down this side, and that sort of like for me takes up a lot of sort of screen real estate. So the first thing I do, and this is great because this is sort of remembered, you only have to do this once, is to set this to top. So activity bar position top, and you're good to go. And this is sort of my default setting for all the work I'm sort of usually work on. So I have my source files here on the left, and then I will have the R console, or I have a terminal. Sorry, I have a terminal session with something I was working on with Claude Code earlier. It's not disappearing. Um, okay, so very simply, and I have some notes here, just like this is like this session is totally unscripted, but this is just some notes of like what I definitely want to cover so I don't go completely off topic. So okay, Act 1, what is Mirai? So um, first things first is launch the package. If you haven't got it installed, then just install it either from CRAN or I would actually encourage you to try and install the development version because there's some nice new features in there that if we have time, I will share with you. And it will be the first time I've revealed these significant new features that will be released, hopefully later this month. And to install the dev version of Mirai, then you can just do pack and oops. Um, sorry. And you can install it from the GitHub repo rlib/Mirai.
So will you be using dev version today?
I will be.
Okay,
And
good to
there's
know.
no difference from what I'm showing you, unless we go into what specifically I've implemented later on if we have time. So if you haven't got it installed, feel free to sort of install it. It will pull in the development version of NanoNext as well, which is what underlies Mirai and powers all the sort of high performance networking. So very quickly, so now I've installed it, then I load the package, and the main function in Mirai is just Mirai. So there's nothing for you to sort of learn. Then there are no options. There are no options or environment variables that you can set with Mirai. Everything is very explicit. The main function is Mirai. So it's really designed so you don't have to sort of remember anything. So to use Mirai, you can just say, oh, sorry, let me just start a new session because I just installed it. Sometimes it doesn't like me running things. So if I just put something in Mirai, and Mirai basically just runs whatever expression in another process. Okay. So you can put anything here. So for example, and any expression. So anything you can put in these brackets. So we can say like sleep sys.sleep 2, and then say have it return done or something like that, right? So when you create a Mirai, this object is a Mirai, and you can see like it's this is the result of this is basically available at data, which is done here. Okay, this is too simple, but if we sorry, this is over too quickly. So if we have this sort of last 10 seconds, then if we look at this object, this isn't actually done yet. You can see this sort of brackets here. This is just the print method, right? And then what we can do is we can say, is it resolved or not? And unresolved. So this is now actually resolved. So this is now finished, right? This task is now finished, and then it will be available at data. Okay. So this sort of shows you that basically when you have this on this is happening in another process, then we're free in our own session to do other tasks. And that is essentially what async is. So um,
This is where I
um,
would love to hop in and ask Lauren's question, which is, what was the motivation or the need for developing Mirai? What problem is this built to solve? So I'm imagining as a person who in undergrad and grad school had to leave her computer running overnight to run projects, that this would mean if you have something that's a very, very long process that's going to take a very long time, you can do something else while you're waiting for that to finish. Am I right?
yes. So there are many ways you can use it. One is as you described. So if you have something like, and sort of my background, I say I'm not a data scientist sort of now. I did do sort of data sciencey type things previously. I was actually sort of building these deep neural nets actually. So I was actually training these neural nets, and then I was actually running inference on them. Sorry. And so I was using Mirai for both of those purposes, right? So first of all, if you have something that's sort of ongoing for a long time, you can run them in parallel in background processes, and that each of them is self-contained. So if something sort of errors and goes wrong in one of them, all your others will still progress to completion, hopefully, because they don't interact with each other. That's one thing. And the second part is really what led me to develop Mirai, which is I was actually running inference with one of these neural nets, one of these models, right? And I was actually also ingesting real-time data. And so this was actually financial market data that I was ingesting through an API in real time and trying to run this through this model and then save the inference results in basically a kind of database, right? So because this all had to happen in real time, then I couldn't afford to just run things in a sort of a normal loop because if something falls over, then that basically stops the whole thing. So what Mirai can allow you to do is it can allow you to offload different tasks into different processes so that your main loop can stay reactive. So essentially, your main loop, you're not doing very much at all in it. You're just checking to see if other parts of that you need are all done. So whether that's ingesting data or that's writing data, those can be done in separate processes. And you can have basically redundancy and sort of fail over in your main loop. That is a very sort of high level overview, um, but hopefully that makes sense to everyone.
Well, we got like seven more questions based off of that answer. So I would say that it makes a little bit of sense, but we need more context. So do you
Sure.
want to give another code example and then we can hop in with more questions?
Excellent. Let me go through some more of what I want to show you. So so I was on here, right? So we here if so one way we can sort of work with async is we have this thing that's running another process, and then in Mirai, if you do these brackets, right, this is the collect method. So this is actually equivalent. This is basically collect Mirai, right? This basically says it's already done, but this will actually wait for the Mirai to complete and then return the result. So if I do this again, then this will actually wait. So this is basically parallel. This is not really async while you're waiting. But this is one way that you can sort of get the results. But this is where you can pair Mirai with promises. to actually have actions happen as soon as a result is complete without you having to wait for it. So this works something like this. And this is basically how Mirai with Shiny works. So Shiny, everything is async. Your Shiny server serves many different users. You can't have that server sort of like stop and wait for one particular user to finish. So if I load up the promises package, yeah. So what I can do here is again, if I say something uh, if I say sleep, and then that basically if I just return a value, and then how promises work is you can say, once that's done, then do something else with the return value. And here, like an example I like using is just to use the beeper function, and it will like play a sound. So here's, this Mirai is going to run for two seconds, then it's going to return two, and then it's going to call beeper beep two, which is the second beep sound. Um, and I realized like you don't hear this, right?
No, no, no. You'd have to share your system sound. We'll trust you that your computer just beeped,
Okay,
though.
so like, okay, you're gonna have to trust me, but this basically goes bling. So this is like it's like a sort of Mario sound. Like yeah,
Like you're
um,
getting a coin in Mario.
like yeah, exactly. It's the coin sound. Um, and so this is sort of like how this works, and that sound plays without me having to sort of interact. And to give you a more sort of concrete example of how this sort of works, if I do a Mirai map, so this is basically the equivalent of lapply or per map, but this basically maps each individual element in a different background process, right? So if I map sort of this thing to a function, um, and then this just sleeps for the specified number, so from 1 to 5 seconds, and returns that number. And this mirror map has an argument which is called dot promise, and basically works exactly the same as promises then. So we can pass a function to this, and again, if we use beeper and beep, then this will sort of play all the first 5 beeps in 5 seconds. And let me try and switch the microphone so that you can actually hear.
If you just hit the share button again, then you can click share system sound and it should let you do it.
Uh, I think I just did it anyway. Sure. If I just play this. Oh, okay. So I hit an error. So this is basically telling me that I need to set daemons. So I can just click through here and set daemons. So daemons, again, is another piece of jargon. Daemons are basically just workers. They are background processes, right? And the reason it asked me to set daemons for this map is for a map, here I'm mapping only 5 elements, but that map could be over like 100 or 1,000 elements, right? And if daemons weren't set, then you'd basically be launching 1,000 different sessions on your own machine, and that will probably crash your machine. So for a map, it will ask you to set the daemons beforehand because it's usually a sort of an oversight or mistake, as it was in this case. So I've just gone ahead and set 6 daemons, which are basically background processes. At any time in Mirai, there's a function which is just info, and you can see like exactly the status of what's happened. So we have 6 connections here. Okay. We'll go through what the rest means in a bit. So if I just attempt that function again, then hopefully you heard that right. Okay.
Nope, but it's
Oh,
okay.
oh, you didn't. Oh, sorry. What do I need to?
You would need to you need to hit the share button, and then you might have to hit advanced and then share system sound, or there's a little checkbox on the right that says share system sound. But it's okay if it doesn't work out, it's all right. We
Oh,
have about 50 questions, so I say
sure,
that
sure.
we get some questions in here because there's a lot of confusion, right? Like there's a lot of things that you have talked about, like future promises, things that we don't have any context for. So let's dig into some of these really quickly here.
Go for it.
Um, one of them is from Nathan. Do the contents of Mirai inherit definitions from the global environment?
No, and this is a conscious sort of design decision, and it helps you sort of avoid mistakes.
Okay.
Um, and like this is sort of like to my mind, this is how sort of things are meant to be. And I know that Future like does it differently. And that package has been around for a while, so people sort of know that behavior. But there are various sort of cases there, and um, the sort of the danger in trying to sort of automatically sort of infer what's sort of in your Mirai can lead to sort of well, in the best case, it can lead to errors, but like the worst case, like it's subtly wrong and you get a plausible answer and you don't even know you're wrong. So that arguably is sort of worse. Mirai is sort of very explicit in that sense, and I'll show you exactly what I mean. So if I define something like slow funk, right? This say just function and this um, just again just sleeps and then it returns something like done. Okay. So if I attempt to sort of run Mirai slow funk, right? You might think that would work. Um, But what you would actually see is there's an error, and it just says error could not find function slow funk because Mirai runs your expression in another process, and this is a clean process. Every time you call Mirai, that is like a clean invocation. There's nothing in that evaluation environment. So what you would do here is you can call it, but then you would pass in slow funk to the Mirai. So something like this, right? So the expression is the same, slow funk, but then you would define slow funk inside the Mirai is the slow funk, which is this function that's living in my current environment. Okay, and then we get the result we expect.
Okay, so you have mentioned future and promises again, and you were like, everyone knows what that is. Charlie, we do not. So if you could give us a little primer on the difference between Mirai and promises and future. One of the questions was like, wait, I'm confused. Why would I choose Mirai versus promises or future?
Um, So promises is a way, basically, as I showed, to have actions occur when your Mirai or your future completes. So they're designed to be used together, and they do different things. A Mirai or future is just a way to run um, an expression in another process, right? Either in parallel or async.
Okay. So things like future and promises keep things running during these like long running tasks where if you have a chain of tasks that need to happen, for example, in a Shiny app, right, that need to happen one after another or reactive to each other, some of those future tasks need to be set aside and stored so that they can happen once something has finished running and they can all happen all at one time. Does that sound right? Or like they can all happen in order.
Yes, so a promise will be basically promise uses these verbs like then, right? So this is the key function from promises. Sorry, that's not very helpful. So
Source code.
it's basically, when you have a Mirai and that's finished, then take the return value from that and pipe it into another function.
Okay. So Renato in the chat says, wait, I'm lost. Aren't our functions run sequentially anyway?
Okay, so let me maybe just go through like the second part of my
Will that answer it
what
for
I
us?
had what I had in sort of what I wanted to demonstrate. So like sequential is basically so you're right. R is single threaded. So without a package like Mirai, everything will run sequentially. And Mirai is basically designed to overcome that. And why this is important? Well, I mean, R has been around for, 30 years or so. I mean, back then, you were lucky if you had sort of, two or four cores. That was sort of the sort of the norm. But, modern laptop has at least 8 cores. My MacBook, I have 14 cores, and all your computations in R by default only uses one single core. So easiest way to sort of demonstrate that is if I define a function again, long task. If I just define that as, and again, I'm sort of using these generic functions because it's easier for me to control sort of how long they take rather than like an actual function that takes a long time. So this will just sleep for 2 seconds and then return the number. Okay. So if I actually sort of time how long this takes, then if I apply this to say 5 and long task, right? Then 5 times 2, you expect this to last 10 seconds. Um, as you can see. And you're sort of this is just sleeping for 2 seconds, but you can imagine that could be doing some kind of either complex sort of matrix multiplications. You could be doing sort of or you could be like hitting some kind of API and waiting for sort of data to come in, right? So that what you would want is for those to run in parallel. So or if we set 6 daemons, which are 6 workers, then if we do the same thing and time sort of a Mirai map, which is the parallel equivalent of lapply, um, long task, and here we actually wait for these to complete because otherwise it will return immediately. Then we can see that because they're done in parallel, this whole thing only takes 2 seconds.
All right, that made a lot more sense to my brain. We have each of these elements assigned to a different process, and they can all happen at the same time. So I
That's right.
can say, I can be like, all right, I have these um, let's say 5 modeling tasks, I think, in statistical modeling. So I have these 5 modeling tasks, and they're going to take a while because they are each going to iterate over a bunch of things themselves. And I can run all of them at the same time on different cores of my computer. And I don't have to keep my laptop awake overnight in order to run them all and get all of those and wait for all of them sequentially to run on the same core.
That's right. And these, I mean, they don't have to be sort of, even sort of simple functions. They can be really they can be full scripts, and you can literally do Mirai, and you can say, you can literally say source whatever, whatever file you have, and it can run your entire script, which, may take hours, it may take days even, right? And you can have them running um, in different processes. And the key about Mirai is with Mirai, you don't need to care like whether that's just running in another process on your own machine. So you're sort of utilizing all the cores that your laptop has, or if they're running in processes on another machine. So if you have like a network server, right? If you have a workstation where you can send jobs,
Yep,
or if you're,
distributed.
yeah, distributed, exactly. If you're at a university and you have access to like an HPC cluster, Mirai allows you to do all of that. And hopefully we'll have time where I can just show you something very simple.
I'm glad that you said that because I've been holding on to Hubert's question because I knew we are going to get there. Hubert had asked, "Wait, can you use Mirai with the HPC?" Yes, absolutely. So we're
Yes,
distributing the work between cores right now on our laptop, on Charlie's laptop,
yes.
but we can assign distributed machines as our workers with Mirai as well, and we can scale up and down depending on our needs. Right, Charlie?
Great. And hopefully I before we run out of time, I want to just go through this code because again, you've hit the nail on the head. There are two sort of core reasons why you would want to use Mirai. And the first is you can scale up and down the resources you need dynamically. So if you decide you need more workers to sort of crunch the tasks that you have on hand, you can simply add more workers. These things aren't fixed. And what I want to show you is basically how this happens, right? So Mirai basically works as if you think about it as a kind of a hub model, right? So when you set up daemons, this basically you set up like something that listens for incoming connections, right? So what you can do is you can set up daemons with a URL. So this, and we have this helper function called local URL. So if you do that, then what happens is that sets up what you can think of as a base station. This listens for incoming connections from your daemons, from daemons that are started, right? As long as they have access to this URL, then they can connect in, and um, um, then you have a worker that's connected. So if I set this up, then this info um, function is going to come in handy. You can see that there are no connections at the moment. And what you can do is you can launch local daemons with this function, launch local, sorry, not local, local, launch local. Um, okay, so launch
We're
local.
scrambling Charlie's brain, y'all.
Yeah, and you can say something like, launch 4 local processes. And that basically goes ahead and does that. So if we look again, we have 4 processes. So we can do things like, if I just evaluate Mirai, like nothing, then we can see that, oh, well, we have one task that's completed here, right? Just to check that something's happening. And, assuming we've set this up and, we can be running lots of things. So I'm just going to copy this thing here. So this just runs a bunch of long tasks. Okay, so there are 2 that's executing, 5 that's completed, and now all 7 tasks have completed. But if you have a bunch of things and you realize you have a large backlog, then you can basically simply just launch more daemons. So you can say, oh, I want to launch add another 4 daemons. And now we basically have 8 workers online. So any tasks that have been queued will just automatically use the number of available workers.
Okay, wait. Pause
And
for two seconds. We have produced demons. We have created demons automatically. Do we need to manually close them? Same with these processes that we're launching or these connections
mhm,
that we're launching. Do we need
mhm.
to
I mean,
explicitly close both demons and connections?
yes. So, I mean, demons are connections. I mean, they're the same thing.
Okay,
And
good.
these, it's always good practice to close them, and the way to do that is to set demons to 0, and that will
Perfect.
close them straight away. But if you forget to close them and you just end your R session, they will all disappear as well. There's no danger of sort of leaving hanging processes at all. They're all, as soon as the connection drops, they're all designed to terminate themselves.
Perfect.
Um, yes, but if you have a script or if you have a markdown document, it's always good to pair a daemons with a daemon 0 at the end.
Okay, great. I interrupted you. We have 15 minutes left. We still have so many questions, but I would love for you
Yes.
to be able to finish your thought.
I thought I was going to have too much time, which is
I
why I
know.
sort of like overdid the
I told
introduction.
you.
And okay, so the second part, um, apart from sort of the scaling and sort of ability to add and subtract daemons at any time, is you can run them anywhere. So if you just do daemons and the number, this will just launch processes on your own machine. Okay. But those processes can also be another machine. And there are different ways you can launch them. One is over SSH, one is via cluster manager. That's if you have access to a cluster. The other is via Posit Workbench. So if you're lucky enough to be in an enterprise sort of environment that actually has Workbench, you can easily launch workers as Workbench jobs. But I won't cover that. I will try and cover SSH as an example. Okay. So the way you do that is you call daemons and you create a URL, which is using this helper, which is host URL. Okay. So this creates a network socket, which is available to other computers on your network. So other computers will be able to connect to this address, this URL, right? And if I do that again, like nothing's connected yet. And what I can do is I can create a remote configuration. And in this case, this will be an SSH configuration. And again, we have these helpers that really sort of like minimize what needs to be done. So here I create an SSH configuration, and there are arguments, but the only required argument is this remote argument, and that is simply the URL of the computer that you have SSH access to. So to give you an example, I switch to my terminal here. If I have, sorry, this is just, so I'm actually connected to a VPN. So I have access. So if I can have SSH, right, so /p, this is the port that you connect to, and this is the address. of the machine that you can connect to. Sorry, here. And if I have access to this machine over SSH, and so this is like I'm actually running on this machine. So I have a MacBook, but this is connected to a Linux machine now. I'm going to just exit out of that. But essentially that URL there, which was 192.168.0.101, that's the only information I need to set up this configuration in Mirai. Okay, so once I have that, then I can actually launch, use launch remote, so not launch local, launch remote. So again, I can launch maybe 2 daemons, and I can pass that configuration in. Okay. And see what happened. Oh, so we have a timer. So again, this is this is useful because again, as I was explaining, how Mirai works is you spin up this basically like this base station, right? Which listens for incoming connections. That means the computer that you have SSH access to has to be able to dial in to the machine that you're running Mirai on. And in this case, that's not possible because I don't have these ports that are opened on my local laptop. Fortunately, Mirai allows you to connect using SSH tunneling. So SSH tunneling, again, like people tend to get confused, so I will try and explain it in as simple terms as possible. SSH tunneling is basically when you connect to a computer using SSH, that creates a tunnel immediately. So imagine there's a tunnel between the two sides. Now, instead of a connection being made between the two sides, each side connects to a local port. So if I'm as Mirai, if I set daemons, I'm listening to a local port, and then on the daemon side, that computer is dialing to a local port. And then the tunnel basically bridges the two sides. So there's no longer any connection from that computer to my computer.
They're
And
connected to an intermediary.
yes, and like very concretely, if you follow this, you will get it. So if I just if I just shut down the previous daemons, and in this case, what I'm going to do is I'm going to create a local UL, right? So this is not the UL that's open to other computers on the network. This is a local UL. I'm going to set TCP equals true because this is a TCP connection. If I use status, this just gives me a little bit more information than info, but you can see we're actually listening to this 127, this address, which is the local host address. So I'm now listening to a port on my own computer. And this is the port that the tunnel is going to be opened on. I can then create this SSH configuration. And again, I can connect to this address is 192.168.0.101. And I actually need to use this port because that's how I've configured that. And I just need to specify this argument, which is tunnel equals true. Okay.
I
And
feel like
then
a hacker right now.
if I try
Tunneling.
and if I try and launch now using this this configuration, this should now hopefully work. So yay, now
We did it.
I have two workers, and they are on another machine that I have that's in London. It's actually a very old sort of converted Mac Mini actually, but it's running Linux now. And to prove to you that it's running Linux, I'm gonna run like Mirai, and I'm just gonna ask for the sys.info, okay? From the worker, and you can see that, hey, this is running Linux. And just to prove that I'm not running Linux, um, this is my machine. It's definitely some form of Mac. Okay, that was a whirlwind, but if you got that, you'll understand how sort of SSH timing. But as you can see, all he had to do was create this configuration, which is just this URL, which is if you can access that machine over SSH, you have all the information you need to run Mirai over SSH.
Okay. Charlie, this was so much information all at one time. We have so many questions that we will not be able to get to all of them, but I want in our last 4 or 5 minutes here to see if we can get to some of them. So one of them from Brent was, I believe NumPy distributes calculations over multiple cores. So does Mirai allow R to perform the same thing as well?
Yes, it does. And the NumPy is very specific, so it will run only numerical um, work that NumPy handles. Mirai allows you to run arbitrary R expressions. So it's anything you can do in R, you can put in Mirai. That's the difference.
Great, any R processes. Okay, Dan had also asked, does Mirai ship with some kind of task viewing dashboard, like Python's visualization, so that you don't have to type info over and over?
Not built in.
Not built in. Okay, great. Let's see. We had another question that was, can we use parallel detect cores to see how many daemons we can use? I really like this question because I
Right,
don't know how many
sure.
daemons I would have access to.
And that's a great question. And
Yeah,
like Mirai by design forces you to actually specify the number you want. So that can be, that can be 14, which is sort of the number of cores I have on my laptop. So you can use something like parallel detect cores or whatever.
bam.
But you can easily be on a server with 256 cores or something, and like sometimes you don't want to use all your cores because you might be running something else, right? So like it never has that context. You running a automatic function. The other reason is this, like you might want to be using all your cores if what you're doing is compute intensive, right? You want to sort of utilize all your cores. Fine. But instead, if what you're doing is actually waiting on I/O, so this is like if you're requesting like a download, right? That is actually not taking all your computation power. So for those kind of tasks, you might actually want to use more than the number of cores you have. So you might want to use like 28, like if all you're doing is like querying some remote API. So that's also another reason why like I don't sort of try and assume like the number that people want. And yeah,
Okay, so with our last 2 minutes, Zach said he had to leave, but he had a great question. He said, in typical data science work, would parallel processing be more useful than async processing, do you think?
yes. If and Mirai actually powers a lot of things sort of under the hood, right? So if you're using parallel per, that uses Mirai, so you set daemons, but you use the normal per syntax, and that is just parallel. It's not async. Where async really sort of comes into its own is if you're using Mirai with Shiny or you're using Mirai with something like Plumber 2. So again, Mirai powers Plumber 2 under the hood. So if you use an async function in Plumber 2, that implicitly uses Mirai.
Awesome. Okay, I bet we can get in one more question. One more. So Rob had asked, can you print progress slash percentages that only get shown on call, like while things are running? I think that's what that's asking.
Yes, right. So very quickly, if you do like a Mirai map, one of the collection options, so instead of just collecting, is you can do like progress, and that gives you a progress indicator.
Aha, okay, cool.
Please carry on while I do something.
I'm going through and just looking at all these questions. I think that I will get with Charlie since we are out of time, and we'll see if we can answer some of these. There was one from Notobeko, there was one from David Diaz, and they look like they could be answered pretty quickly, so we'll answer them in the chat after the session. Charlie will help.
Excellent.
All
The
right.
last thing I want to mention, oh no, I'm out of time. There
You
is
are
a
out of
there
time.
there is a Mirai skill. So if you folks out have access to Claude Code or Open Code or some great AI agent, install the rlib skill Mirai, and you can just invoke that. You can you can transform all your sort of normal scripts into parallel and async code.
Amazing. Oh, I just spelled sorcery wrong in the chat. Don't at me. Hold on. Let's fix it. All right. Thank you so much, Charlie. That was amazing. You're getting thank yous in the chat. Thank you for being patient with us while we all try to muddle through what async is, what parallel is, what Mirai does, what future and promises are. I think we all learned a lot and have a lot to like go Google and think about. I wish that I knew about this in undergrad and grad school. I definitely didn't, and it would have helped my life quality of life with coding so much. So thank you so much. We will get with Charlie to answer some of the more simple questions afterwards in the chat. We will see you all on Thursday at the Data Science Hangout if you would like. Thank you, everybody. Have a fantastic week. I'll see you when you see you. Thanks, Pauline. Thanks, everybody. Bye. Thank you, Charlie.